I hope you gone through this statement, because this is the today ideal question, right? We have in the daily Leetcode question, right? So this is the Leetcode questions we have Tuesday and April 22, right? And we got this question for the solve, right? So I hope you gone through the statement and the example, right? But let me read for you so we can go through the intuition and the writing the code step by step. Okay, so the question is saying that count the number of ideal arrays. So you are given two integers n and max value, which are used to describe an ideal array. A zero index integer array, that is array of length n, is considered ideal if the following condition met or hold. So every a of I is a value from 1 to max value. Within the range, I should be greater than or equal to 0 to n and should be less than n, and every array at I is divisible by array at I minus 1 for all I greater than or equal to greater than 0 and should be less than n. We have to return the number of distinct ideal array of length n, distinct ideal array of length n. Since the answer may be very large, we have to take a modulo of 10 to the 9 plus 7, right? Then you can go through the statement here as let me expand a little bit. Okay, so input we have given n is 2, max value is given 5, right? And output is 10. So the following are the possible ideal array. So array starting from the 1, right? It will go to 5 arrays: 1 1 1 2 1 3 1 4 1 5. Similarly for 2 array, 3 1 for 1 array, right? Like that we have here. Okay, so there are total 5 plus 2 plus 1 plus 1 plus 1 is 10 distinct ideal array. Okay, means you can pause this video and you can go through this so I can explain here better. I don't want to interrupt you for understanding and thinking. Okay, let's pause for 2 minutes and we'll come back. Okay, so we have given two numbers, right? I'm going to first explain the intuition so you will understand the problem behind, right? What is the intuition behind the problem, right? So we have given two numbers, right? The first is n itself. N is the you can say integer, right? And max value is the integer, right? So n, the length of the array, and max value is the maximum number any element in the array can be, right? And we need to count the number of ideal arrays of length n, right? That is done, right? Three things we have here. Means first we have given n, then we have given max value, and then what we have to do? We have to return the number of distinct ideal array of length n. Means we need to count the number of ideal arrays of length n where every element is between 1 and max value and every element is divisible by previous one. That is array at I, right? Array at I is divisible by array at I minus 1 equal to 0. It should be divisible. Divisible means this value should divide this one, right? And it should come equal to 0, right? So what is the core intuition if you think about, right? So let's suppose if an array at I, right, is 6. If array at I is 6, the next element can be 6, 12, 18, etc, right? But not just any number. So the array builds up using multiplies, right? Let's suppose I'm saying if the array having the value 6, right? Array at I is 6, means the next element can be what? 6, 12, 18, etc, right? Similarly, but not just any number. So the array builds up using multiplies, right? So if so, what are the combinations is here? So if we'll find the sequences 1 to 4, these are multiple ways to fill a length 5 array using this pattern, right? So you can go with 1 1 1 4 2 4 1 1 2 4, like that we can write some patterns, right? We can write like similarly he has done here, right? N is equal to 2, max value is 6, right? So we can write like this, right? There is more possibilities are there, right? We can do that. So these combinations and the repetitions problem, it will count all the factor chains, right? of the length. So you can use combinations, like we can use n minus 1, k minus 1, right? If we can find all the combinations. So this is the goal we have, right? Means what is our goal is here? We'll count all the factor chains of length k, and we'll use the combination c of n minus 1, k minus 1, right? Like that we are doing, right? To count how they can be ranged in the array of the length n. This is little you can say a hard question, right? So you have to go through step by step to understand the scenario, right? So this is the intuition, guys, we have. And so I'll try to start from here, right? So I'll greet everyone. Hey everyone, in this video we will tackle an exciting problem from the Leetcode, and we'll count the number of ideal arrays. So let's understand what makes an ideal array and how we can solve this smartly using the math and recursion, right? So let me slide this one a little bit. Okay, so what we have given first, two things we have given, right? The integer n and the max value. Integer n and max value we have given, and the maximum allowed element is the max value, right? And this is the length of the array. Clear? Means we have given, or you are given two numbers, n and the max value, right? So n is the number of and the array length, and max value is the maximum allowed element, right? And an array is ideal if every element divides the next one, right? That is a ideal one, right? And what we have to do, your task is to count how many such arrays exist. If that is the case, you are getting so many, take a modulo of 10 to the 9 plus 7, right? And yes, and then what we will do, so let's go with the understanding what we have to do. So first of all, let's suppose we have n is 2, right? As you can say, we have n is 2 and max value is 5, right? So these are the possibilities that we found, right, for all these, right? So what is our observation is here, right? So at the first glance, right, we can go with brute force. That might seems tempting, but it also slow, right? It is also too slow, right? So here is the trick. Think of the sequence 1 to 4 building block, right? Think of the building block 1 to 4 as the building block, and each valid chain can be extended to the length of n using the combinations. So if you have 1 to 4, right, then multiple arrays of the length 5 using the combinations we can create, right? You can pause the video and you can write for this type of things, and you will understand them, right? If you not understand this, then take 1 to 4, and if you do the multiple arrays, right, of the length 5, right, then what you will find, you will see the combinations are there, right? So the algorithm strategy is to we will generate all the multiple chains using the DFS. Then what we will do, we'll count how many chains exist for each length, and we will for each we will calculate combination c of n minus 1 k minus 1, right, for all n, right? And to see how many ways we can extend, right? Then what we will do, we'll generate the chains, we'll count all the length, and we will use the combinations, right? Like that we will do, and then we will find these values, right? So as you can see here, first step, we will declare the combinations because we have to store somewhere, and to compute the combinations of the Pascal triangles, we will use like we'll go through the for all the n, and c n minus 1 and k minus 1 will do, right? And we'll do the count, right? We'll find the count, and then what we will do, we'll prepare the array to store the count, right? See, this is your array, and we'll do the count, right? And for every number, we'll do DFS, right? So to DFS, we will call this function, right, DFS function, and then we'll create letter, and then we'll use the combinations, right? And you know the combinations, right? You have to find the total, right? So we will make the chain count and we will find the value. So for the DFS, right, what we will do here, we'll pass current and then length and the max value and the chain count here, right, and the chain count will get increases, and you will have you will do the DFS to the next level. So we have to apply here. We will keep multiplying, because multiple of 2, if you will say, let's suppose we are talking about 6, next is 12, 13, right, like that we will do 18 will do. So we have to take the multiple, and then we have to multiply with this for loop, and you will find the DFS, right, again. And so it will keep updating its current, its length, and the max value will stay here, and chain count. Like that we have to keep moving forward to compute this value. So to understand this, you have to go through the combinations and the Pascal's theory, right, we have to go through. But this is little mathematical problem, right, and I hope you will understand this problem by doing multiple times, right. You focus, you do by your own, and let me know if you need anything from here, and if you have any doubt in this video, I'm zooming here so you can take a notes and you can implement. So first you have to define the 2D array to the combinations, then you have to write the ideal array, and you have to go through all the steps, right, first to compute the combinations, and then you will go to store the all the chain counts here, right, and for that all the chain counts, first we will go through the DFS for every numbers from 1 to the max value, and from the DFS you will explore all the multiple chains, right, and then you will use the combinations to count valid arrays, and then you can make the step 4 to do, and then you will get all the combinations, and you will have the count total, and you will finally return the total, right. So that's it, and this is the efficient and elegant solution, guys. So use DFS and combinations, we handle up to 10 to the 4 values, and please smash the like button if you learned something new today, and subscribe for more algorithm that made it easy. If you still have any issue in this problem and you are not getting something, so please suggest, write the comment, and I'll help you. Thank you for watching this video.